Greetings, everybody. Learning as a hobby here. Um, Watching through the video that I posted yesterday, I noticed that there was a mistake in question 10, part D. I made a calculation error. So the curves that we got as the solution for that were not accurate. So I want to actually just post a quick video to fix that problem here, just so I don't have, leave an incorrect statement on the video there. So, but I don't want to re-record that whole video because just to fix one problem. So I'm just going to record this one short video to fix the error there. So let me just bring up the correction here. So the problem was with part D of question 10, which said this: make a guess about the shape of the curves formed by the set of all p satisfying d1, d2 equals b when b is greater than a squared and when b is less than a squared. He's referring to the picture here. Let me just scroll down. In the original video, when I was doing this derivation here, let me just show you where the mistake was so you can fix it in your notes if you're following along. I forgot to write this factor of r squared here, which gave slightly different curves as the solution to the problem. So just putting this factor back in, this is the correct polar form of the curve that he's describing in question D. Then to solve for r, we have to use actually the quadratic formula. You bring everything on one side. R is our variable here. So solving for r squared, you get this expression. Again, just by using just by using the quadratic formula. And then solving for r, you get plus or minus this expression here. So this gives you the equation of the curves in question in part D, and depending on whether b is greater than or equal to a squared, tells you the sign of this term here, and that affects the shape of the graph. So I'll show you some examples like I did yesterday in Desmos. But what happens is if b is less than a squared, then you get two branches contained completely inside the original lemniscate. And if b is greater than a squared, you get one branch that contains the original lemniscate. So again, let me just go to Desmos just so you can see what the graphs look like, or some examples of the graphs, what they look like. So let me just share my screen here where I graphed these on Desmos. All right, so here's what the graphs look like. So the first two, the graph in green is when b is less than a squared. So notice that actually this is sort of like a typical example here. Here I have a to the, what is it, a to the 4 minus b squared being negative 0.7. So in that case, you get the green curves that I have here. Notice you get two branches. Actually, let me just show you. They come in pieces. So for the positive version here, when you have plus the square root of cosine squared 2 theta minus 0.7, you get these outer branches. These are outer parts of the two branches. And for the negative part, you get the inner part of the two branches, and taken together, you get the green, the two branches of the green curve here. So that's when, actually, that would be when b is greater than a squared, right? Because you get a negative. Let me just double check back into the equation that I have here, because you have a to the 4 minus b squared. That would be, oh, okay, so that would be when b is greater than a squared. And then going back to Desmos. Sorry, here we go. Then if the constant is positive, so in other words, when b is less than a squared, which I have graphed in purple, you get a curve that completely contains the original lemniscate. The original lemniscate I have drawn in red. This is for the value a equals 1. So I just chose an easy value for a. All right, and as the constant gets larger, I think that dimple sort of like evens out. So for example, here if the constant is 1, notice that the dimple it's getting less dimpled in the middle, I guess, right? Then you have, let's say 5. Notice that it's again the dimple gets more and more ironed out. If we go even larger, again, it's, you know, becoming more and more like elliptic shaped. So that's what the actual graphs look like. So I just wanted to correct that mistake. Let me just go back to the notes here. So for that part, where's my pen? So for that part in question D, this is what the graphs look like. The equation of the graph looks like when B is greater or less than a squared. Right. So this is the equation for the curves. Right. So again, if you want to correct that in your notes, it's because I forgot this factor of r squared. All right. So let me just stop the screen share. All right, let me know if you guys have any questions or anything in the comments. And I'll post this video also in the description bar to that video, just so you know, if people are looking at it, that they'll be aware that there's an error in that solution. All right, guys. So you know, these things happen, right? It's self-study. I don't have anyone checking my work, but I do, just so you know, I do look at the videos just to see if I can catch any mistakes. And I do usually fix them if I can in the description bar. This one, though, was a little bit too long to fix in the description bar, so I wanted to make a short video about it. Anyway, I'll see you guys in the next one, which will be Chapter 2 in Taylor. So until that time, keep learning, everybody, and I'll see you then.